Welcome to Learning to Engineer. Before we start solving this problem, let me ask you a quick question. You have a heater in your home. 230 volt 50 Hz supply is given to it. What is the value of the frequency of instantaneous power? I repeat, what is the frequency of the instantaneous power that is used by this heater? You can take 10 seconds to just think about it and tell me your answers. It is 100 Hz. You are supplying voltage in the frequency of 50 Hz. So, what is the frequency of the power? I'll do the calculation. We all know that instantaneous power is instantaneous voltage times the instantaneous current, right? We do not know the current because we need to calculate it based on the load's ratings. Okay? So we only know the voltage that is supplied to it. So this will be V square T divided by R. This is 230 cos omega T whole square divided by R. Correct? So this will be 230 square divided by R into 1 plus cos 2 omega T divided by 2. I have simplified cos square theta as 1 plus cos 2 theta divided by 2. Using that formula, I simplified this. I hope you would have got the answer by now. So this implies that if you multiply inside, you will be getting 230 square divided by R plus 230 square divided by 2R into cos 2 omega T. Okay, so what is the frequency now? The angular frequency is 2 omega. So 2 omega will be 2 into 2 pi f. F is the linear frequency, omega is the angular frequency. So this is 2 pi into 2 into 50. I have told you that the heater receives a power supply of 50 Hz to 30 volt, right? So F is 50. So this will be 2 pi into 100. Therefore, the instantaneous frequency of the power will be 100 Hz. In the previous video, we had discussed about the instantaneous power, average power, complex power, active power and reactive power. So based on all these concepts, we also solved a problem. Now we are going to solve another problem, a bit different one, using those concepts. In this system, you are supplying a voltage of 240 volt RMS and 50 Hz. You have three load resistances connected in parallel to it. One is 80 minus J50, other one is 20 minus J70 and the last one is 60. If you observe, you could say that this is a resistor, this one is resistor and inductor combination, this one is resistor and capacitor combination. If you don't understand how I reduced it, just let me know your thoughts in the comment section. Okay, so we'll just head to the problem. We need to find out the total complex power and power factor of this system. Okay, so what is complex power? Complex power is denoted by S. S will be active power plus J reactive power. Active power is the power that is used by the load and reactive power is the power that is sent back to the supply. Okay, all these details we have seen in this video. So for more details, you can just watch that. Active power will be Vrms, Irms into cos phi. Reactive power will be Vrms, Irms into sin phi. This is the rectangular form of complex power. Okay, so now let us see the polar form of complex power. It is denoted as voltage into conjugate of the current. Okay, where the magnitude of this will be Vrms into Irms, and angle will be phi. Okay, so now we need to find out the total complex power. From this problem, we can see that if we have active power and reactive power, we can get the complex power. So for that, what are the things that we need? Vrms is given in the problem. It is 240 volt. We need to find out Irms, right? And then we need to find out cos phi or the power factor. Once we know cos phi, we can know phi. So once we know phi, we can find out sin phi. Okay, so our first work is to find out Irms or the current that is supplied to this system. Okay, so from Ohm's law we know that current is voltage divided by the resistance. Here Irms will be Vrms divided by the impedance ZL, which is the parallel combination of these three resistances. Let me first find that out and then I will substitute here. The effective impedance will be 80 minus 50J parallel with 120 plus 70J parallel with 60. So we will first find out the parallel combination of both of them and then we will consider this. Okay, so this will be, we have two impedances in parallel. So the effective impedance will be product of them divided by the sum of them. Okay, so if I multiply 60 inside, I will be getting 60 into 120, 7200 plus 60 into 70j, which is 4200j, divided by the sum of these two, which is 120 plus 60, 180 plus 70j. We don't have an imaginary term here. So now we need to find out the product of these two divided by the sum of these two. So for that, we will first simplify this term and then put it here. In order to simplify, we need to convert that into polar form. So we have converted this term into polar form. So now we need to perform multiplication as well as addition, because when you are finding out the effective resistance of two resistors in parallel, the numerator will be RA times RB divided by RA plus RB. So in the denominator, you need to perform addition operation of these two terms. So for addition, you need to know, yes, the rectangular form. So to know the method to convert rectangular form to polar form without your calculator, you can just click this link. Okay. So I'm just going to calculate this for you. Now we have it in the polar form as well as in the rectangular form. So this will be, I'm just replacing the division term by this. You can also replace that by the polar form. Both are same. We are going to multiply the numerator, so therefore we need both of them in the polar form. We know the polar form of this, which is 43.15 angle 9 degree. We need to find out the polar form of 80 minus 50j. So the polar form will be, so now we have found out the effective value of this resistance, which is the parallel combination of these three resistances. We use the polar form and rectangular form interchangeably, and then we arrived at the answer of 31.30 angle minus 3.61 degrees. We will substitute the value of ZL in this equation. So now we have found out Irms. So our next job is to find cos phi. How to find out the angle phi or the power factor? If you remember, I would have told you that power factor is the difference in angle between the angle of the voltage minus the angle of the current. How to find both of them? For voltage we know it is 0 degree. For current, what is the angle? It is 7.66 angle 3.61 degrees. Okay? Or there is another method. Whenever you get the total impedance, the angle of the impedance will be power factor angle. Okay? Remember very clearly the angle of this impedance or minus 3.61, right? That is the power factor angle. Let me show you how. Okay? In general, what is impedance? Impedance is voltage divided by the current, right? If you express this in the RMS values, you will be getting Vrms with some angle, let us say theta V, divided by Irms, let us say the angle is theta I. So, Vrms by Irms, what is it? Resistance, which is the total resistance. Okay, and the difference in angles? Angle, since they are in division operation, it is theta V minus theta I. Okay, so this is the value of the impedance, which is magnitude, and the angle is theta V minus theta I. What is theta V minus theta I? Power factor angle, right? So whenever you get the impedance angle, I mean this in the sense total impedance, not only one single load. You have to consider the entire load, and whatever is the angle of the entire load, that will be the angle of the power factor. Cos of minus 3.61 degrees, which is, it should come something close to 1 because cos 0 is 1, right? Minus 3.61 degrees is somewhere close to 0, right? So let us check. Cos of minus theta is going to be cos theta as long as it's in the fourth quadrant and the first quadrant. So we don't have to bother about the sign here. So this is 0.998. So you have a power factor that is something close to unity. So this indicates that the system is a very good system and there will be minimum power losses. Okay, so we will find out active power first, next the reactive power, then we can find out complex power. Okay, so now we have found out cos phi. Let us also find out sin phi so that it will be useful for us to find out reactive power. Okay, so this implies that the active power will be Vrms Irms cos phi, which is 240 into 7.66 into cos phi, which is 0.998. I'm just writing the value here. 1834.72 watt. Okay, so this implies that the reactive power will be same, 240 into 7.66 into sin phi. What is sin phi? Sin of minus 3.61, which is minus 0.6062. Okay, so we have found out the active power and then the reactive power. So we now have active power and then reactive power. So what is complex power? S is equal to 1834.72 plus J minus 113.98. So this is the value of the complex power. We have found out the complex power as this, and the power factor. What is power factor? Cos phi. Cos phi is this 0.998. So we have found out both these values now. So in this circuit, if you observe, the power factor is close to unity. So there will be no losses. What will happen if this power factor is something close to 0.5? What will happen if this power factor is something close to 0.8, 0.9 or something like this? So all these details and what will happen if the power factor is less, what losses will occur, all these will be discussed in detail in the next video. Thanks for watching. Let me know your thoughts in the comment section and subscribe to my channel for more updates on similar content. You can also ring the notification bell so that you don't miss any timely update. Thank you.